Imagine waking up one morning to breaking news. Humanity has decided to launch every nuclear weapon on Earth toward Jupiter, the largest planet in our solar system. The mission, to see if we can blow up this gas giant and rewrite the cosmic order. But is such a thing even possible? What would happen if we tried? And most importantly, what consequences would we face? Buckle up, because this thought experiment is about to take us on a wild ride through space, nuclear physics, and the very fabric of the universe. Before we even think about nuking Jupiter, let's take a closer look at the power we're dealing with. Nuclear weapons come in two main types: fission bombs, which split atoms apart, and fusion bombs, which fuse atoms together to release even greater energy. The largest bomb ever detonated, the Tsar Bomba, released an explosion 3,800 times more powerful than the Hiroshima bomb. Yet, even such an explosion would be a mere spark compared to the titanic scale of Jupiter. In fact, Jupiter is so massive that it could fit over 1,300 Earths inside it. Its thick atmosphere is primarily composed of hydrogen and helium, the same elements that fuel the sun's nuclear reactions. So, what if we introduced our most powerful weapons into this mix? To even attempt this audacious experiment, we first need to transport Earth's entire nuclear arsenal to Jupiter. That's roughly 12,700 nuclear warheads, most of which belong to the United States and Russia. But getting these warheads across the 590 to 970 million kilometers, 365 to 600 million miles between Earth and Jupiter is no small feat. Historically, spacecraft like the Galileo probe have taken up to 5 years to reach Jupiter. However, since our nukes wouldn't need to slow down upon arrival, we could shave off some time and get there in about 550 to 650 days. Even so, this journey is filled with obstacles. The biggest challenge: navigating through the asteroid belt without accidentally detonating our entire nuclear stockpile mid-transit. To ensure a safe passage, scientists would need to carefully chart a course through the Kirkwood gaps, regions in the asteroid belt with fewer objects. Even a minor miscalculation could result in a disastrous chain reaction, vaporizing the warheads long before they ever reach Jupiter. Assuming we successfully deliver our nuclear payload, what happens next? The moment the warheads hit Jupiter's thick atmosphere, a spectacular chain of explosions would unfold. Fireballs of unimaginable size would light up the planet's skies, creating shockwaves that ripple across the gaseous surface. From Earth, we might witness massive flashes of light, similar to when comet Shoemaker-Levy 9 collided with Jupiter in 1994. However, even though this comet's impact released more energy than the world's largest nuclear bomb, Jupiter barely flinched. Here's why. Despite our bombs reaching temperatures hotter than the Sun, Jupiter's atmosphere lacks the density needed to sustain nuclear fusion on a large scale. In other words, the explosions would be powerful, but ineffective at causing a chain reaction that could destroy the planet. If we truly wanted to obliterate Jupiter, we'd need an amount of energy equivalent to the Sun's output over 160 years. To put that into perspective, this would require about 1 billion nuclear bombs, far more than the 12,700 we currently have on Earth. Even if we somehow built that many bombs, we'd face another problem: the sheer mass required to create them. To construct enough warheads, we'd need a material mass nearly twice the size of Ganymede, Jupiter's largest moon. That's more mass than Pluto and Mercury combined. At this point, it's clear that trying to nuke Jupiter into oblivion is an exercise in futility. But this raises an even more important question: should we even attempt such an act in the first place? Destroying Jupiter might sound like a harmless thought experiment, but in reality, it would have profound consequences for our entire solar system. Jupiter's immense gravity plays a critical role in shielding Earth from rogue asteroids and comets. By eliminating it, we could unintentionally increase the likelihood of catastrophic asteroid impacts on Earth. Furthermore, if Jupiter's mass were suddenly removed, the delicate balance of planetary orbits could be thrown into chaos. The gravitational pull it exerts on Saturn, Uranus, and even Earth could shift, leading to unpredictable changes in our solar system structure. There's also the question of whether we have the right to do such a thing. Throughout history, humanity has wielded great power, often with unintended consequences. From nuclear testing to environmental destruction, our actions have repeatedly shown that tampering with natural forces on a massive scale can lead to disaster. If we look to history, we can find numerous examples of experiments that went horribly wrong. One such case is the Castle Bravo nuclear test in 1954. Scientists miscalculated the explosive yield, leading to a blast twice as powerful as expected. The fallout contaminated thousands of square kilometers, affecting nearby populations. Similarly, in 1986, the Chernobyl nuclear disaster showed the devastating consequences of unchecked nuclear energy. A failed safety test led to a catastrophic explosion, releasing radioactive material that affected millions. Both of these events serve as stark reminders that even when we think we understand the power we wield, unforeseen consequences can emerge. If detonating a single reactor on Earth can cause such destruction, imagine the repercussions of igniting thousands of nuclear warheads on a planetary scale. While the idea of nuking Jupiter is a fascinating mental exercise, it ultimately reveals the limits of human power in the face of the cosmos. Despite our most advanced weapons, Jupiter would remain largely unscathed, and the potential risks far outweigh any scientific curiosity. Instead of seeking to destroy, perhaps we should focus on exploring and understanding. Jupiter holds many secrets, from its enigmatic great red spot to the possibility of life beneath the icy crust of its moon, Europa. Rather than sending bombs, we should be sending probes, satellites, and even future astronauts to uncover the mysteries of this gas giant. In the end, the universe is vast, powerful, and often beyond our control. Rather than attempting to rewrite the cosmos, perhaps the real lesson is learning how to exist within it responsibly. Instead of asking, "What if we nuked Jupiter?" perhaps we should be asking, "What if we used our technological power to advance humanity in meaningful ways?" Whether it's space exploration, clean energy, or medical breakthroughs, the greatest impact we can make is not in destruction, but in discovery.